Good afternoon, everyone. Today's topic is carbonyl group, and the last topic will be the separation and identification of different organic compounds, the techniques such as mass spectrometer, NMR, nuclear magnetic resonance, and infrared spectroscopy. That we'll discuss next class. Today we'll discuss about the carbonyl groups. So first, what we have aldehyde and ketones. We already discussed how to name these compounds. If it's an aldehyde, the name should have Al, and if ketone is there, the name should end at ONE. As you can see, there are two carbon atoms, that's why it is eth. Between them, there is a single bond, that's why it is N. And the functional group C double bonded with O and H. The aldehyde group is there, which is always at the end, which is refers to the first carbon. So it is al ethanol. But if you have three carbon atoms, you can see the three carbon atoms, and C double bonded with O carbonyl group is there at the center. So because of three carbon, it's prop. They have a single bond. That's why we say N. And due to the C double bonded with O, it's known as one. So propanone. Now, solubility, like dissolve like when the substances have identical or same type of forces, they are miscible or soluble. So as you can see, C double bonded with O, so oxygen is having a lone pair. Here also C double bonded with O, so oxygen is having a lone pair of electron. So in carbonyl groups, the C double bonded with O, which is having a lone pair, is this lone pair is actually attracted towards the hydrogen of water. Oxygen is partial negative, hydrogen is partial positive. As oxygen is partial negative, it will attract the bonded pair between hydrogen and oxygen. So this bonded pair almost shifted towards the oxygen. So the hydrogen which get a partial positive is attracted towards the lone pair which is present on the oxygen of carbonyl group. So this makes them water soluble. But as the number of the carbon increases, as the chain length increases, the solubility decreases. What is the reason for that? Because as the chain length increase, then the effective force will be dipole, induced dipole force, which is due to the carbon chain. So smaller carbonyl compounds are water soluble, but as the number of the carbon increase in the chain, the solubility decreases. But if we have a pure carbonyl groups, they don't tend to form hydrogen bond with each other. Why? Because, for example, if you have, say, ethanol, so in case of this ethanol, the ethanol molecule with another ethanol molecule cannot form hydrogen bond. Why it cannot form a hydrogen bond? For formation of the hydrogen bond, the hydrogen must be attached directly to oxygen, fluorine, or nitrogen. But in this case, you have one molecule of ethanol, then there's another molecule of ethanol. So these two molecules are not able to form hydrogen bond. Why they are not able to form hydrogen bond with each other? Because you can see the hydrogen is not directly attached to any one of these most electronegative element, such as oxygen, fluorine, or nitrogen. Then the reactions of carbonyl, how the reaction will occur. As we can see, when we predict the geometry of these carbonyl groups, it will be trigonal planar. Why trigonal planar? Because if you have C double bonded with O and CH3 is there and even H is there, even aldehyde or a ketone. So when we predict the geometry, the central carbon atom, when we take between oxygen and carbon, there's a double bond. So when we predict the geometry, we will consider that as one bond. Then there's another bond with hydrogen and another bond with carbon group, alkyl group. So 3 bond pairs are there. There is no lone pair. So the bond angle will be 120 and it will be trigonal planar. So how the reaction will occur for this trigonal planar? Oxygen is partial negative because oxygen is more electronegative and carbon is partial positive. So the nucleophile, the electron deficient, attracted towards the electron deficient side or positive center. So this nucleophile can attack on this carbon partial positive ion and undergo a reaction. Normally a nucleophilic substitution reactor or nucleophilic addition reaction. Here you will, depending on what reagent we use, so it can be a substitution or addition. Then when we oxidize, if we have a primary alcohol first oxidize to aldehyde and then aldehyde further oxidize to carboxylic. If it is a secondary alcohol, it will oxidize to ketone, and tertiary alcohol cannot be oxidized. This is how we can form these aldehyde or ketone. So if we want to form aldehyde, we can use partial oxidation, a simple distillation to obtain this aldehyde. If we want a complete oxidation of a secondary alcohol, we can use reflux condenser. So first oxidation means addition of oxygen or removal of the hydrogen. Both are refers to. So if you have aldehyde can be oxidized to carboxylic acid. If the condition reheat under reflux, you will use dilute sulfuric acid and potassium dichromate, which is an oxidizing agent. So acidified potassium dichromate you can also mention. The equation aldehyde, you can see ethanol reacted with potassium dichromate in the presence of acid, the protons. It formed carboxylic acid, water, and chromium in dichromate ion. Chromium is +6, which is orange in color. As it reduced to +3, it will change from orange to green. This can also be used as a test to distinguish between aldehyde and ketone, because aldehyde can be oxidized, ketone cannot be oxidized. So what we can do, we can use toluene reagent or we can use Fehling or Benedict solution. So what is a toluene reagent? It is a complex compound which contain a silver ion. So if a solution is aldehyde, any kind of aldehyde, so that aldehyde will oxidize to carboxylic acid. Why we call this oxidation? Because it is an addition of oxygen, that's why it's oxidation. And silver ion is reduced to silver atom. This is also known as a silver mirror test, toluene reagent or a silver mirror test. So what is a toluene reagent? It is formed by mixing ammonia with silver nitrate. So it will form a complex compound of silver, and when we add this to a compound aldehyde, any aldehyde will oxidize to carboxylic acid and silver ion is reduced to silver atom and it will form a silver layer, a silver metal. Or the second test is known as a Fehling or Benedict solution. A Fehling solution, also it's a complex compound ion is there which contain copper 2. Copper 2 is blue in color. So if aldehyde is there, aldehyde again, it will oxidize to carboxylic acid, and copper, which is +2, is reduced to copper 1. So what it will form? Copper 1 oxide. It is insoluble. As a result, it will form red precipitates. Is it clear, this part? Then reduction. So what reagent which we use? We use lithium tetrahydrodualuminate in a dry ether. Ether is a solvent. So it's the same thing as we know. if oxidation of primary alcohol, first it's oxidized to aldehyde and then aldehyde oxidized to carboxylic acid. Oxidation of a secondary alcohol will produce ketone, and tertiary cannot be oxidized. So opposite, if we reduce them, so if we have aldehyde, if we reduce aldehyde, it will be reduced back to alcohol, primary alcohol. If it's a ketone, then it will reduce back to secondary alcohol. And even if you have carboxylic acid, like if you in the beginning you have carboxylic acid, so carboxylic acid also it was reduced, but it will not reduce step by reduction like first carboxylic to aldehyde and then to primary alcohol. Directly it will be reduced to primary alcohol. So reagent is LiAlH4 in a dry ether. Room temperature and pressure, this reaction can proceed. The reaction type is reduction. And role of the reagent, why we use this lithium tetrahydrodualuminate, it will act as a reducing agent. Then addition of hydrogen cyanide. You have to learn the mechanism of this reaction and how this reaction proceeds to form hydroxynitrile. So the reaction is we are converting carbonyl group into hydroxynitrile. What reagent we use? We use hydrogen cyanide in the presence of potassium cyanide. And it can occur also at a room temperature. The mechanism is known as nucleophilic addition. Why nucleophilic addition? Because only one product will be there when this reaction occurs. That's why we call nucleophilic addition reaction. So basically what happened, the reaction mechanism for this, as we know, these carbonyl groups, even at aldehyde or a ketone, these groups trigonal planar, the C double bonded with O, example CH3 is there, and CH3. So first is we have a mixture of hydrogen cyanide plus potassium cyanide. Hydrogen cyanide, the dissociation is H plus and Cn minus. And potassium cyanide, potassium is plus and Cn is minus, so it will dissociate into K plus and Cn minus. Now, what happened, how the reaction occur? First thing, you have hydrogen cyanide. This is a reversible reaction, like and the second is dissociation of KCN, which contain K plus ion and cyanide minus ion. This is a nucleophile. So first, this CN ion will attack. The oxygen is partial negative because it is more electronegative, and carbon is partial positive. There's a lone pair, and the negative charge is there on CN9. So it is attracted towards electron deficient side. But it can attack from any side as it's a trigonal planar. So it can attack from the left hand side, it can attack from right hand side. So when carbon attack, the nitrile group attack on the carbon, the oxygen will take the bonded pair. So as the oxygen will take the bonded pair, the intermediate oxygen will have a negative charge because oxygen took both of the electron which are involved in the bonding between them, carbon and oxygen. CH3 is there, CH3 and CN. Now, as you can see, CH3, CH3 and CN is there. We have, as we add, like example, if we have more potassium cyanide, so this is a reversible reaction. So because of higher percentage or greater amount of this carbonyl group, nitrile group, the equilibrium is shifted toward left hand side. As the equilibrium is shifted toward left hand side, we'll have HCN molecules. So what happened in this HCN molecule? Oxygen, which is having extra electrons and a negative charge, so oxygen will use that electron to form a bond with hydrogen, and nitrile group will take the bonded pair. So as a result, what will be the final product? So it will be OH, CN, CH3, and CH3. Then how to name this? So we'll select the longest carbon chain. So this is the longest carbon chain, 3. Second position, we have hydroxy. Second position, we have methyl group. So 2 hydroxy, 2 methyl, and 3 carbon are there prop, single bond N, and due to this CN group, it is nitrile. So 2 hydroxy, 2 methyl, propane, nitrile. So you can see what is the advantage of using a mixture of hydrogen cyanide and potassium cyanide. As initially the cyanide is coming from potassium, and that started the reaction, but then what happened, because we have HCN molecules are there, so every time the proton is removed from this HCN, and as a result it produces another nitrile group, and this nitrile can attack on another molecule of a carbonyl, and the reaction will continue. Is it clear the mechanism? Nucleophilic addition reaction for hydrogen cyanide to carbonyl group. Then reaction of carbonyl with iodine in the presence of alkali. This is also known as triiodomethane reaction. And this reaction is used to identify, if we want to test that next to carbonyl group, if there is an alkyl group, like basically methyl group, if next to carbonyl, if there is a methyl group, then this will be a positive test. It will form a yellow precipitate, iodoform test also. If there is no, like example, if we have a carbonyl group, but next to carbonyl group there is no methyl group directly attached, if directly methyl group is not attached, then this will be a negative result. So what we do, reagent which we use this for this reaction, we use iodine and sodium hydroxide, and we warm gently. Then what happen, as you can see, example, if you have propanol, this is propanol. So in case of propanol, it is CH3, C double bonded with O, and CH3. So when you warm this with sodium hydroxide and iodine, so what will be the reaction? It will form triiodomethane, basically CH3. One of the CH3 is removed, iodine is added, so it will form triiodomethane plus sodium ethanoate plus sodium iodide and water. So this triiodomethane, what is the appearance? It is a yellow solid, and it is having an antiseptic smell, so which confirm that next to carbonyl group there is a methyl group. So same way you can see here, CH3, C double bonded with O, CH2, CH3. So next to carbonyl there is a methyl group, so this will also give a positive result. Triiodomethane will be there, ester will be there, ester salt, and sodium iodide plus water. There is also another way to test, identify whether we have an aldehyde or a ketone. So we call that as tri 2,4-dinitrophenyl hydrazine derivative. We can use this to find which aldehyde or ketone is there. So what we do in this reaction, this is 2,4-dinitrophenyl hydrazine. You can see from the 1, 2, 3, 4, 5, 6. So second position and fourth position, we have nitro group. That's why 2,4-dinitro. D stands for di and N stands for nitro. Phenyl group, when amine and groups are attached to the benzene ring, this is called a benzene ring, which is having an alternative double bond, vibratory double bond. So we call that as a phenyl group. So 2,4-dinitro phenyl hydrogen. So because of this NH2 and NH, it is hydrogen. So how this will give a result, how we carry out this. So we form a precipitate derivative of this 2,4-dinitrophenyl hydrazine. So first we have 2,4-dinitrophenyl hydrazine and then we add it to a compound, either aldehyde or a ketone. So how the reaction will occur? Basically, there's a lone pair on this nitrogen, so this lone pair will form a bond with carbon, and hydrogen is removed, which form a bond with oxygen. And you can see both are linked with each other. So first is addition of the water, the first stage. Then elimination of the water. Basically what happened, the water is being removed. And how the water is removed? Because H and OH. So if OH is removed from here and H is removed with nitrogen, so there will be a double bond between them. And this is known as a derivative of 2,4-dinitrophenyl hydrazine, which is orange precipitate. Now, how we can find which aldehyde or ketone is there? So we can check the boiling point of this. Check the melting point or the boiling point. Normally, it's because it is a solid, so we check the melting point. So when we check the melting point, each derivative, according to, like example, a derivative of 2,4-dinitrophenyl hydrazine, which is formed with the propanol, will have a different boiling point as compared to which is formed with ethanol. Is it clear? And how it is done? So first we add 2,4-dinitrophenyl hydrazine to the compound which we want to identify. We don't, because we don't know which compound is there. We're just identifying which compound present. Then we will warm the solution and filter and then cool down. After cooling down, we filter it off again, recrystallize, and check the boiling point of the precipitates. The carboxylic groups C double bonded with O and OH, that's known as a carboxylic. And their acids, what is the tendency of the acids? Acids are proton donors, so they tend to donate proton or give out proton. And as you can see, in case of carboxylic groups, we have C double bonded with O and OH. So they can form, they have permanent dipole due to C double bonded with O, and they can also have hydrogen bond because of OH bond. Oxygen attached with hydrogen, so can form hydrogen bond. So they are miscible. So smaller carboxylic acid up to C4 dissolve in water in all proportion. Like any amount you add, you can find it dissolve. But uh, the solubility decreases as the number of the carbon increases. And hydrogen bond in a solid ethanoic acid. So because what happened, the hydrogen bond between the dimer in a solid ethanoic acid, and that's why the solid ethanoic acid appear to have a melting point, uh, a molar mass, so for relative molecular mass of 120. So what is the reason for that? Because like this is one molecule of ethanoic acid, and then the another molecule of ethanoic acid, C double bonded with O. So there's a lone pair, and the lone pair. So this lone pair is attracted towards hydrogen, form hydrogen bond, lone pair attracted, form a hydrogen bond. And why its relative molecular mass appear to be 120? Because when you find the mass of one molecule of ethanoic acid, 2 carbon, 24, plus 2 oxygen will be there, 32, and 4 hydrogen are there. So total for one molecule is 60, but because two molecules link tightly packed together and strong bond is there, so appear to be solid at room temperature with a relative molecular mass of 120, because they are linked by hydrogen bond. So it appear that this is one molecule. Then what happened? Like the X-ray diffraction shows that the bond length is same for C double bonded with O and COH. Because normally what happen, acids are proton donors. So C double bonded with O and OH is there. So when it donated proton, this hydrogen or proton it donate. So as a result, it will be C double bonded with O and single bonded with O. So one side, this will be partial negative because hydrogen is being lost and both of the electrons are taken by the oxygen. But when we pass X-ray and check the bond length, we find that the bond lengths are same, identical, because this is not a stationary double bond. This is a vibratory double bond. Means what happened? Like you have C double bonded with O. First, oxygen and carbon, they have a double bond at the top, but next moment the double bond is between the first oxygen, which was having a single bond, and the top oxygen will now have a single bond. So it is continuously vibrating. So the pi charge cloud delocalize and spread out, make this ion more stable. Therefore, more likely, because if ions are stable, it can form. Otherwise, if it was a stationary double bond, so it will be highly reactive, and this ion, we don't find this ion in a solution. The strength of the carboxylic acids. So how we can compare these strength of the carboxylic? As we know, alkyl groups are also known as electron releasing groups. So what if something is releasing the electron, so increasing a chain length pushes the electron density onto a C double bonded with O and O, which make it more negative and less stable. So this make acid less strong. Like the acid, because the acid, the tendency, acids are proton donor. So once it donated its proton, but because these alkyl groups are known as electron releasing groups, so they supply electron to this carbon. Means electrons are pushed towards this carbon. So if electrons are pushed towards this carbon, already there is a oxygen and carbon double bond. So this bond cannot vibrate easily. So this cause, or it will make more negative, or it make it less stable. But if it is, for example, a carbon chain is there which is having chlorine. So chlorine is electron withdrawing group, means it has tendency to take or accept electrons. So when it has tendency to accept electron, what it will make, the electronegativity of a chlorine atom withdraw the electron density, which make it less negative and more stable, and this make the acid more stronger. So means if an acid, the side chain of an acid having electron releasing group, the acid will be weaker. If it is having a group like such as chlorine, fluorine, which are electron withdrawing groups, then it increases the like it will make the acid stronger and increase the stability of the ion in the solution. So chloroethanoic acid is more acidic than normal ethanoic acid. And we can also say, like when we are comparing, propanoic acid is less acidic than ethanoic acid. Less acidic means smaller value of dissociation constant or Ka. More acidic means greater or higher value of Ka. Is it clear, this part? Then methods of preparing carboxylic acid. If you want to prepare carboxylic acid, we have primary alcohol. We can use heat under reflux in the presence of oxidizing agent, excess of oxidizing agent such as potassium dichromate 6 and sulfuric acid. So which cause like propanol oxidize to, first it will oxidize to propanol and then propanol oxidize to propanoic acid. Then oxidation of aldehyde, we can also, if we have aldehyde, can also oxidize to carboxylic acid. Or hydrolysis of the nitrile groups. Hydrolysis means breakdown of a molecule by the help of water, we call hydrolysis. So if we have a nitrile group, you can see propanitrile, and we are using dilute hydrochloric acid and sulfuric acid. Acids are aqueous, so this dissociate this into carboxylic acid, propanoic acid plus ammonium ion will be there. If it is HCl, hydrochloric acid, so ammonium chloride will be there. Sulfuric acid, so ammonium sulfate will be there. Reactions of carboxylic acid, the reduction reaction. So carboxylic acid can be reduced to primary alcohol. The reaction condition, room temperature and pressure. We use lithium tetrahydrodualuminate, which will reduce this propanoic acid into propanol. The reactions, carboxylic acids are weak acids. When acid react with metal, it result in a salt and hydrogen. So we'll observe phase bubbles, solid dissolve. If acid react with an alkali, we use an indicator for this type of reaction and identify how much acid neutralizing an alkali. Or acid react with carbonate, result in a formation of salt, water, and carbon dioxide. The carboxylic acid cannot be oxidized by using oxidizing agent, but only the methanoic acid is exception. So methanoic acid is exception here, because what happened in methanoic acid? So carboxylic acid cannot be oxidized except for methanoic. So what happened in methanoic acid? As you can see, C double bonded with O and OH is there. So this will result as addition of oxygen is called oxidation. So it forms a carbonic acid, which is H2CO3, which can decompose to give carbon dioxide. So oxygen is added to this and H2CO3 will be there, which is carbonic acid. which decompose to give carbon dioxide. Then test to check the presence of OH group. This test is valid for both alcohol. This will give a positive result with alcohol as well as carboxylic groups. So we can use a PCl5, phosphorus pentachloride. At room temperature, when we add this PCl5, so chlorine will take position of displace this OH. So it will form CH3, C double bonded with O and Cl. Acyl chloride is there, POCl3 and HCl. So whenever HCl is there, this will be result in a formation of the misty fumes. Even alcohol, normal alcohol is there. Like if you have, say, methanol reacted with PCl5, this will result chloromethane plus PCl3 plus HCl and result in a formation of misty fumes. And this HCl misty fumes, it will turn into dense smoke if we add aqueous ammonia or bring near to the bottle of ammonia. Esterification. Esterification means formation of ester. When alcohol react with carboxylic acid, this will result in a formation of ester and water. This esterification is a reversible reaction. So when carboxylic acid, the first name of ester is from alcohol and the second name is from carboxylic. Like example, if you have ethanoic acid and ethanol, so the first name is from alcohol, ethyl, and the second name is from carboxylic acid, ethanoate. So ethyl ethanoate will be there as a product. The condition, the reaction is reversible, which is a very slow reaction. So you have to heat under reflux and often about for several hours or days. It's a lower yield is achieved as a catalyst. H2SO4 is required. Then opposite, hydrolysis. Hydrolysis means breakdown of a molecule by the help of water. So we can have acid hydrolysis, we can have base hydrolysis. So if we have ethyl propanoate example, so the first name of ester is coming from alcohol and the second name is coming from carboxylic acid. So it will be ethanol and propanoic acid. So ethanol and propanoic acid will be the product. But if we carry out this reaction in alkaline condition, then the reaction is not a reversible. Like it cannot have the carboxylic and alcohol cannot react back to form. Reason for that, first when we do hydrolysis, the base hydrolysis, so for methyl plus propanoate, methyl propanoate decompose into methanol plus propanoic acid. But the propanoic acid which is formed reacted with sodium hydroxide, which will form sodium propanoate. So the reaction cannot be reversed. So this reaction goes to completion. So if you want to hydrolyze ester, we use base or alkali hydrolysis, which is irreversible. If acid hydrolysis is done, it is reversible, so which reduce the yield of ester. Then what's the meaning of a trans esterification? So normally like the vegetable oil can be converted into a biodiesel by reacting with methanol in the presence of strong alkali acting as a catalyst, and this process is known as trans esterification. Means one ester is converted into another ester. We call that as trans esterification. So you can see first this compound is an ester. We reacted with methanol. It will form propane 1,2,3 triol and a new ester is formed. This ester is a biodiesel. And why we call this biodiesel? What we We can say this biodiesel, which is produced as a carbon neutral. Why a carbon neutral? Because the raw materials are from the plants, and when we release them, burn, use as a fuel, so same amount of carbon dioxide is released, which was absorbed by the plant. But in reality, like when we are comparing, you cannot say something is 100% carbon neutral. Why? Because you're not taking into account like irrigation plants, extraction of the oil, heating for the reaction, and methanol mixture or a process for the fuel. So these things are neglected. So overall, we can say it is a carbon neutral fuel. Acyl chlorides, when C double bonded with O and CH3 is there, we call them as acyl chloride. Two carbon atom, that's why Eth, single bond N, and because of C double bonded with O and Cl, it's oil chloride. And their reactions can occur at a room temperature. Like example, if you want to form alcohol, carboxylic acid, so if acyl chloride is added to water, what we observe, we'll observe a steamy white fumes because of HCl, and it will form carboxylic acid. If acyl chloride react with alcohol, it will form ester, and again it will misty fumes or steamy white fumes will be there. And this formation of ester from acyl chloride is more efficient as compared to directly reacting with alcohol and carboxylic acid, which is a reversible reaction. Then reaction with ammonia. So how the reaction with ammonia occur? We have CH3, C double bonded with O and Cl reacted with ammonia. So ammonia is NH3, in which NH2 and H. So this one is partial negative, partial positive, partial negative, positive. So NH2 group will take position of Cl, and Cl will displace this NH2. So it will form this C double bonded with O and N, that's called amide. So it will form ethane amide, and ammonium chloride is there. So ammonium chloride, which is a white smoke. Same thing, acyl chloride react with alkyl amines. So it will form N methyl, because methyl group is attached to nitrogen. Two carbon atoms are there, Eth, single bond N, and amide groups. So reaction with ammonia or reaction with primary amine, similar pattern is there, but one, so it is forming that directly amide group is there, C double bonded with ONN, and here amide group with a carbon chain. Then polyester or polymerization, basically when a small molecule join to form a long chain compound, this process is known as polymerization. So there are two types of polymerization: addition and condensation. Addition polymerization occur in alkene, and condensation polymerization can occur when carboxylic acid is reacting with alcohol, when alcohol is reacting with another alcohol, or amine is reacting with carboxylic, or even acyl group is reacting with alcohol. So as we know, if we have a reaction like carboxylic and alcohol, it will form ester plus water. But if we have dicarbo, means both ends we have carboxylic group and both ends we have alcohol, so it will form polyester and water. Same thing, acyl chloride plus alcohol, ester and, but diacyl chloride and diol are there, so polyester and hydrogen chloride. And this is known as condensation polymerization, because a small molecule such as water or HCl is given off along with the polymer. So you can see formation of tyrrolene, a common polyester which we use. So this is dicarboxylic acid and diol. So one side If you remove H, the other side you should remove OH. One side you remove H, the other side you remove OH, and then link them together. This will be a polyester, and which is having an ester linkage. Same way, if you have acyl chloride with diacyl chloride with diol, so this will remove H will be Cl will be there, and H will be there. Hence, Cl will be there, and H is there, and they link with each other. Again, a ester linkage or a polyester is formed. Same way, if we have 2-hydroxypropanoic acid, so 2-hydroxypropanoic acid, one side we have carboxylic, one side we have OH. So what we will do, we'll remove H from one side and OH from another side and link them together. It will form a long chain compound, which is also a polyester. Polyesters can also be hydrolyzed by acid and alkali. So with HCl, the polyester will be split into original, but with sodium hydroxide, because it will form a carboxylic acid and alcohol, that carboxylic acid can react with alkali. So this will result in a formation of salt rather than the original product. Is it clear, this polymerization? Any doubt till now? So this is about carbonyl groups.